Welcome to the lair of the Batty Boffin.
Hi there Batty fans, here's a little bit more all about square roots and surds. This bit is called Rationalising the Denominator, which is a fabulous title and probably good enough to scare the living daylights out of most people. But as most things, it's not as difficult as it sounds once you get to know what you're doing. But before we get into that, first of all, we need to do a little bit of recap on multiplying out these two sets of brackets because we'll need that later on. If you don't know what you're doing with this, then go and look at some of the other Batty Boffin videos on multiplying out quadratic brackets. If you are okay with this, then just follow through the first one and then you're going to do the others. Okay? For the first one here, if you use FOIL, then this is your first two. The a times the x gives you an ax. I'm going to draw my dragon claws, I think. And then the outside 2, the a times the y, gives you an ay. The inside 2, the b times the x, gives me a bx. And the last 2, the b times the y, gives a by. Make sure you are okay doing that. And if you are, pause the video and multiply those out, simplifying where you can. Okay, your turn. Welcome back. We should have, for this first one, a plus b squared is of course the same thing as a plus b times a plus b. So when we multiply out that, we get an a squared plus an ab plus another ab plus a b squared. And that's normally written slightly more compactly as a squared plus 2ab plus b squared. Okay, we've got an ab and an ab. For this last one down here, we've got the first two terms given a squared, then we've got the a times the negative b gives a minus ab, the inside ones give a positive ab, and we've got a b squared at the end. So when we simplify that, we get a squared minus b squared. I hope you're familiar with that as the difference of two squares. If not, check out some other Batty Boffin videos because we will be using this. Okay, so that's just the recap. We're going to be using that to what's called rationalise the denominator. What on earth does that mean? Well, a denominator, that's part of a fraction. You know, the numerator at the top, the denominator at the bottom. So it's talking about the bottom number of a fraction. And to rationalise means to make rational. So hopefully you've heard of rational numbers and irrational numbers. Irrational numbers are the ones you can't write down accurately. Things like pi, for example, is an irrational number. However many decimal places you write it down to, you haven't got it accurate. It doesn't repeat, it doesn't terminate, there's no patterns, it just goes on and on forever and it never ends. Pi is a very famous irrational number. Other irrational numbers are, quite frankly, most square roots. Some square roots, like 9, have a rational root, 3. But if you go for the square root of 3, the square root of 3 is 1.7 blah 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 blah, and it goes on forever, never ends, never repeats. It's an irrational number. Most square roots are irrationals. So when we talk about rationalising, we mean make it into a rational number. Numbers that you can actually write down properly. So basically it's getting rid of all the square roots and stuff. So pause the video while I wipe this down and we'll go through how to rationalise a denominator. Back in a minute. Here I am back again, and we've got some fractions with irrational denominators here. This one also has an irrational numerator, but we'll deal with that later on. It's just the denominator we're wanting to make simple because we can deal with fancy stuff in the top much more easily than fancy stuff in the bottom. So just starting off with this simple one up here, we've got 2 over root 3. Well, there's a very easy way of rationalising that. Remember that anything over itself is just 1. And that anything really can be anything. So what I'm going to do here is just take that fraction and I'm going to multiply it by 1, which of course won't do anything to it. But I'm going to write my 1 as root 3 over root 3. Root 3 over root 3 is 1. The fact that you can't actually write down root 3 as 1 point something 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 is irrelevant. It's just root 3, and when you divide it by root 3, it's 1. So, remembering how to multiply fractions, we multiply across the top, we multiply across the bottom. The top becomes 2 lots of root 3, which is 2 root 3. And the bottom becomes root 3 times root 3. And root 3 times root 3 is 3. Please note it's not 9, it's 3. So there we go. We now have an irrational bit on the top, but that's fine because we've got a rational denominator. So easy peasy. If you've just got a root on the bottom, just multiply by that and it will instantly become a rational number. Rational numbers are any numbers you can write down exactly, basically integers, terminating decimals, fractions, that kind of thing. Or yeah, the nice repeating decimals like 1/3. Okay, this second one down here. Now, we can't just multiply top and bottom by root 3 because we'll end up with that 2. We'll have a 2 root 3 in it in there. Here's where we employ that very clever difference of 2 squares thing. What I'm going to do here is multiply top and bottom by the same thing, but I'm going to multiply it by this. Watch, magic. 2 minus root 3 on the bottom and the same on the top. 2 minus root 3. It may be a complicated thing, but it is still just the same number top and bottom, so we're multiplying by 1. Right, when we multiply the top by 5 on here, please make sure it's 5 times everything. Sorry, that should be a times in there. 5 times all of that. Okay, so you end up with 5 times 2, that's 10. Take away 5 times root 3, we just write as 5. I made a mess of that, haven't I? Take away 5 root 3. That's better. And that doesn't simplify, okay? It's just how it is. The bottom, however, we note that we've got our difference of 2 squares. The difference of 2 squares is when you have a plus b times by a minus b. If you're not sure about that, go and review it. I'll just write a little reminder up here. When we have a plus b multiplied by a minus b, the answer is a squared minus b squared. And there's no ab term because you get a positive ab from one of them and a negative ab from the other, and they cancel out. You may think that's just a nice, interesting, pretty thing on here, but it's really, really important here because the first thing, whether it's rational or irrational, it ends up squared, so it's going to be rational. The second thing, be it a number or a root, when you square it, it's going to end up as a number, and there is no b on its own, because if b was, say, root 2, and you had an ab, you'd end up with a 3 root 2. That's still irrational, but there's no ab terms in here. Just something squared, which is going to be rational, and something squared, which is going to be rational. So when we multiply these out, we get the 2 times the 2, which is a 4. I'll just write this one out fully. We get the 2 times the negative root 3, which is negative 2 root 3. Irrational term. We get the root 3 times the 2, which is plus 2 root 3. Another irrational. And we get root 3 times root 3. Take away root 3 squared. But of course these cancel out. So there's none of that. Those irrational terms disappear. And root 3 squared is just 3. Please note it's a takeaway. Okay, so that then all simplifies down to 10 minus, done it again, 5 root 3 over 4 take away 3, 1. Rational denominator. Right, last one down here. We've got a rational number top and a rational number on, an irrational number on top and an irrational number on the bottom. So, first thing I'd like you to do is pause the video and tell me what I'm going to multiply top and bottom by. So, pause the video and do that now, please. Right, we should be multiplying by 3 plus root 2 on the top and on the bottom. We've chosen 3 plus root 2 because it's exactly the same as that, just with a different sign. Now for the top, we're going to get something yucky. It's quadratic multiplying here. First two, the 4 times the 3, that's a 12. The outside, it's a 4 times a root 2. The inside, it's a root 2 times a 3. And the last two, it's a root 2 times a root 2, which is 2. And for the bottom, we have a squared, 3 times 3 is 9, minus, must remember it's minus there, b squared, so root 2 times root 2, which is 2. So that simplifies. We've got a 12 plus a 2 is 14. We've got a 4 root 2 plus a 3 root 2, which is 7 root 2. Whole thing over 9 take away 2, which is 7. Oh, look, we've got lots of things cancelled down on there, don't we? Everything cancels by 7s. So that is equal to, cancelling through by 7, 2 plus root 2. That's it, just 2 plus root 2. Very simple. Okay, hope you all got that. So pause the video, go make yourself a cup of tea. I'll be back in a few seconds with a whole board full for you to do. Back soon.
Mwahaha! Mwahaha! Mwahaha!